In this example, we are going to solve the equation for y as a function of x. We're given the equation x squared plus 121 quantity times dy dx is equal to 1. And we're also given the initial condition of 11, 0. So when x is 11, y is 0. And this is going to help us find our constant. So to find y as a function of x, I'm going to isolate dy. And then I can integrate. So to isolate dy, I'm going to divide by x squared plus 121 times dx. Now that this is set up so dy is isolated, I can integrate both sides of the equation. So I have 1 dy, and so when I integrate that, I get y is equal to, and then for this, we need to set up a right triangle and use trig substitution to evaluate that. So I'm going to set up my triangle here. Here's my angle. I have 11x, and then this will give me x squared plus 121. Now, this tells me that tangent theta is equal to x over 11. And then, so that also gives me that x is equal to 11 tangent theta. And if I take the derivative of both sides, that's going to give me 11 secant squared theta. Also, I can use x is equal to 11 tangent theta to solve for theta because we're going to need that later. So I'm going to take x and divide it by 11 and then use inverse tangent. So I have inverse tangent of x over 11. And that's going to give me theta. So when I integrate both sides of the equation, I get 1 dy, and that gives me y equals. And I'm not going to worry about the c there because I'm just going to add the arbitrary c's together on the right-hand side. Now, for this integral on this side, I'm going to replace x's with 11 tangent theta because that's what we have here when we solved for x. So if I square 11, I get 121, and then I square tangent, I get tangent squared. I have plus 121. Now, to put this in terms of theta, I have dx is equal to 11 secant squared theta. So 11 secant squared theta, d theta. I'm going to factor out the 121 in the denominator. And then what's left in the denominator is tangent squared theta plus 1. And tangent squared theta plus 1 is an identity which is equivalent to secant squared. So in the denominator now we have secant squared theta. And on the top I have 11 secant squared theta. So all of this comes down to, once we simplify it, the integral of 11 d theta. So I have y is equal to 1 over 121 times 11 theta plus c when I find the antiderivative. Now theta is equivalent to inverse tangent x over 11. Let's see, tangent inverse x over 11 plus c. We still need to find our value of our constant using our initial condition of 11, 0. So to solve for c, I'm going to plug in 11 for x and 0 for y, and that will help us find c. and I'm going to have 11 over 11 plus c. This is equivalent to pi over 4. So we get 0 is equal to, now 11 over 121, this right here, I can simplify as 1 over 11, times pi over 4 plus c. Now I'm going to subtract pi over 44 from both sides, because if I multiply 1 over 11 times pi over 4, that's going to give me pi over 44. And I'm going to subtract that from both sides. So I find that my constant is negative pi over 44. So now that we have our constant, which is negative pi over 44, we can write down our final answer, which is going to be 11 over 121. This is all equal to y as well. 11 over 121 times tangent or inverse tangent of x over 11. And then plus my constant, which would be minus pi over 44.